All righty, so this exam will be essentially chapter 1. So that's called exploratory data analysis. And it will be slightly chapter 5. I think there are 3 questions from chapter 5. So that's experimental design. So this is exploratory data analysis, and this is experimental design. There are 12 multiple choice and 2 free response. Okay. So from chapter 1, you had better be able to read graphs. So read and interpret graphs, and in particular, you better be able to read and interpret a histogram, make sure you understand a relative frequency histogram. You don't have to make any of these on your test. I'm not going to test whether or not you can, put the class limits in the right place to get a nice looking graph. I'd rather on an exam see how well you can interpret these things. An ogive, you might have to read an ogive. A box plot. And what do you need to be able to interpret from these graphs? You need to try to figure out where essentially the center might be. You need to be able to figure out the shape. And you, from a graph, not generally too much about spread, except in a box plot. So I'll say you should be able to look at a box plot and determine IQR. And on ogives, you need to be able to figure out things like percentages and percentiles. Only on the ogive, where it's pretty clear. Okay? You need to be able to get numerical summaries of any piece of data you get. Numerical summaries meaning you need to be able to find your way around finding a mean and a standard deviation that you won't really have to calculate by hand, but you should know where it is in your calculator in case you have to calculate one, and you might want to kind of get some idea of interpreting that. I think you saw a lot of those problems in the practice test that we went over. You need to be able to find your way through a 5-number summary. You need to know that if you're describing spread, you should be looking at the standard deviation or the IQR. And if you're looking for a center, you should be describing either the mean or the median. Oops. Hang on. Come on. Yes? Good. All right. If your distribution is symmetric, then you'll always want to use the mean with the standard deviation. Now, it's not a hard, fast rule, but if your shape is not symmetric, you'll want to use the median with the IQR. There's nothing wrong with using the median on a symmetric distribution and the IQR. It's just that as the statistics become a little more advanced, we really have a lot of things, a lot more that we can do with means and standard deviations. Medians and IQRs, that's non-parametric statistics, is not quite as an advanced a field, to tell you the truth. So there's not as much as we can do with those. So we like to have symmetric distributions. A lot of the things that we deal with become symmetric distributions. So we will deal a lot more with means and standard deviations. But you get those distributions that are not symmetric, where you have to use the median and the IQR for describing. Okay. As far as shapes of distributions, here, you need to be familiar with symmetric and recognize it. Skewed left or right. So I'm going to say that a skewed left distribution is lower on the left might look something like that. A skewed right distribution is lower on the right. You need to, I did include a problem that mentioned something about a uniform distribution. And uniform distributions essentially have all the bars at the same height. Essentially. They don't have to be exactly the same height to be called uniform. As I tried to make here, I tried to make them not all be the same height. And we're still going to call it uniform, even though this one's a little taller than this one. Yes, ma'am? So yes, you can use mean and standard deviation because it is actually symmetric. And bimodal, I think we talked about it once, but a bimodal distribution will have like a little cluster of values and then a second cluster of values. So you might see the word on the test. So that's why I'm telling you now. And with bimodal, we don't do mean and standard deviation or median and IQR. What we do is we look at our data and we think there's something else going on, that I've got two distinct centers here that I may need to investigate a little bit further, and I may end up splitting my data up into two different groups. So yes, you might see a bimodal distribution tomorrow on your test. All right, back to what, so that's shapes. You need to know how to do an outlier test. Look that up if you don't remember. You need to have an understanding of those linear transformations. So if I add a constant value to each value, what measures change? Do the centers change? Does the mean change? Does the standard deviation change? Okay, let me just say, the centers change, the spreads do not. If I multiply by a scalar, then the centers change, and the spread does change. You have a pretty direct question on that. Okay, words that you need to go back and make sure you're familiar with from chapter 5 stuff and from handouts from class are block design, observational study, what's a survey? What does confounding refer to? What is self-selection? Make sure you look that up because I don't think we've gone over that one particularly a lot, but the word did come up in one of the questions on the test. Hint, hint. What's a census rather than as opposed to a sample? So I'll say census versus sample. When can you infer cause and effect? When can you say that something causes something else? Like, when can you say smoking causes cancer? And when can you say that you actually get a cause and effect relationship and not just a tight association between smoking and cancer? Anybody know? Yep. I would say experiment, but you said controlled experiment, and that's true. Know what a placebo is? Know what a control group is? And be able to describe how to do a random assignment of treatments. All right, as you're studying tonight, if you have some questions, you can post on the School Loop group. I'll check tonight. Certainly you can answer each other's questions if you want to look on the School Loop group. I'll check tonight to see if there's anything I need to address before your test tomorrow. Questions? Yes. How do you randomize on the calculator? So if you want to assign somebody a random placement on a calculator, you would first take everybody in your group and give them a number, like number them off however, 1 to 10, and then in your calculator you would go to math and probability and rand int 1 comma 10, and that doesn't need to be part of this description, but you can just say you can use a random number generator. It can either be paper or calculator to get you a random integer from 1 to 10. And then the first number you pick gets treatment 1. The second number you pick gets treatment 4. Make up a way of doing it so you get an equal assigning of groups. Yes. You're just going to have to explain, so you got to be real clear in your explanation. Okay? But I won't make you pick a sample. Got to make that thing stop happening. We good? I'm good. Come on. Come on. Stop.